The popular and growing photo service has suddenly crashed. How do you handle a major outage? What could the cause be? What changes can you make in the design so this problem doesn't take down the entire service again in the future?
So let's apply this to your photo application. In this case, the photo service has crashed, so you need to ask yourself, how do you handle the outage? What is your coping mechanism? What happened? Let's identify this. How can you prevent it from happening again? Develop a process, have your communication, and ensure that this never happens again. So, the thumbnail service has gone down. Now, all of the back-end thumbnail services were in a single region and zone. The zone was lost for a period, and the service was lost with it. Okay, so it's not a process. It's not a people issue. It's not a behavioral issue. It's a design issue. Because in this case, we lost an entire zone. So how do you deal with it? Well, it really helps to have a process in place, having a plan to deal with a major system outage. The number one thing we always recommend is that you appoint one person to be in charge of the response. You need one single voice to curate and aggregate most of the information that they're getting. This person must hand off carefully, if necessary, until the incident is over. Sometimes people are on call, and you need to make sure there is a rotating pattern of people who can hand over and take over if the problem isn't solved while one person's handling it. Maintain an aggregate log of the incident state and responses. One idea is to mirror a channel in your Slack team with a channel on IRC. Then, when it comes to postmortems, the entire chat log is aggregated and a summary or postmortem report is created. So this way, you'll have all the raw data, the core processor, and then an aggregate for learning processes. Identify the teams that are going to be affected. Let them know, let the customers know. Make it clear who to contact. So establish exactly who the key individuals from those teams are. You don't want everybody joining in and repeating the same thing over and over again. Clean up any loose ends during the incident response and prepare the postmortem report. You always want to determine the root cause. Update your playbooks and your processes, and maybe even consider adding disaster recovery drills in case this happens in the future. Keep an archive of all the actual information, but aggregate that into a final postmortem. So let's go ahead and review here. You want to be able to protect against a zonal outage. The zonal outage took everything out because in this case, everything was zonally based. So you want to move this service to multiple zones. In this case, a decision has been made to split the thumbnail servers between Zone A and Zone B. That's natively supported by your cloud load balancing. You already have built-in zonal redundancy here for data storage, but your upload server will certainly be affected in the future. So when you look at your business logic, you're now ingesting, you're going through image storage. You've put in a front-end load balancer, so you need to load balance to your thumbnail process, followed by your storage, and so on. So you can see here how that affects your logic. Once again, our service level objectives didn't change. We added more redundancy by making the service span multiple zones. So why didn't the SLO values change? It's because the user experience didn't change. The SLO for our availability is still 95.83%. The multi-zone change we made was to ensure we could achieve that SLO. But wait, there's more. There's been another major system outage. All right, what's happened? The photo services crashed again. This time, the zone did not go down, so no excuse there. The thumbnail service went down due to overload. So the upload server is a single point of failure, something identified earlier actually. The machine crashed today due to a server overload, so now you're going to make changes to the design to prevent the overload from happening and to improve resiliency. This one's pretty straightforward. You're going to add and create a distributed set of upload servers. It worked for the thumbnail servers, but these upload servers aren't going to use the standard network load balancer. They're going to be using the HTTP load balancer because these are from your presentation layer, which is web-based. So you're going to put the load balancer in front of the upload servers. You're going to isolate and create additional upload servers distributed across zones. And now your data storage server will be responding back to the upload servers. So you're not going to have an incast or fanning problem. So in this case, you've scaled from the front-end server. The issue was the single upload server, stored user experience, and state information. Now, to scale to multiple upload servers, the servers must become stateless. That's something you identified before. Remember, as a single host, they kept track of everything. But now, this could get a little messy because you're going to be passing a user session state back through to the thumbnail servers. And when you retrieve data from the data storage server, you don't want another server pulling that data that didn't belong to a particular user. So how do you address that? Well, before introducing that, let's talk about some more process. You're going to prevent an overload by making load testing real. If you can, do a dark launch. And if you can't, try to test in a pre-production with a synthetic workload. If you can simulate a production workload, that's always ideal, but you're not always going to have that luxury. While it's self-evident that a test environment should always resemble production, you need to exercise expensive operations as well. So if you can create a simulation of production, then do so. With the ability to do preemptible virtual machines that last for 24 hours, you could easily clone and do an automated deployment of an isolated environment. Be aware that not all load testings are going to be production exemplified, although they're going to be pretty close. So in this situation, in order to scale this properly, you have to break the state out of the upload server. So now, take a look at the logic. Your state information somehow needs to be maintained throughout the entire business logic. Before, everything could be handled by the one server, but that's no longer the case. You're really starting to break out into many different microservices. They're all clustered, and these should all be stateless. So in terms of best practices, you're going to isolate state. So what does that look like? Well, we're going to define some kind of state storage. In this case, that could be Google Cloud Storage. I don't think it's been identified yet, but you know that you need to keep state storage. This way you can pass those back to the upload servers. Now, the thumbnail servers don't really need to do that. All they're doing is looking for an image to put out a thumbnail. And then, of course, the upload servers will retrieve that by basing on the data that's stored in the state storage. So here, you've got an update. Remember, every time you iterate, go ahead and review. Do you have a new service level objective? Well, you're getting pretty popular here. An hour of downtime for every month is certainly not going to be acceptable. You need to start achieving real production level SLOs, so you want to maintain a 99.9% availability. That's also going to change how you test and how you deploy, because you don't even want intentional downtime as a result of deployments. So this means your downtime budget is only 43 minutes per month, and that's not a whole lot of time. And that indicates planned downtime. So this might change how you do deployments as well. So think of that process. That's why you start with an objective. You see what it is that you can measure and then quantify it.